Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Welcome to this Advanced Tips and Techniques series for SolidWorks. This is episode 9, Advanced Modeling Part 5. And today we're going to be talking about all things boundary feature. Boundary feature is one of my favorite features in SolidWorks because it's so versatile and it is vitally important to consumer product design because of the many complex shapes that it can create. So this is what I'm going to attempt to cover today, and we probably will spill over into a part 2 for boundary because there is so much to talk about. But I will try to get through as much of this today, and then we'll pick it up with episode 10. So, boundary. What is boundary and how is it used? Well, I think to answer that question, we need to compare it against some of the other more popular features in SolidWorks. So you're undoubtedly familiar with Loft. Boundary is very, very similar to Loft. In fact, it generally replaces all of the functionality of Loft with some important distinctions. Boundary is basically used to define a surface between boundaries, usually 2 first direction curves or 2 first direction and 2 second direction curves. It is unlike sweep, which is generally defining a profile and sweeping it along a path, or along a path and guide curves. The fill feature is different from boundary or loft or sweep in that it can intelligently fill multiple boundaries, that is 3 or 5 or more. And I'll show you in a slide where that becomes important in just a moment here. And then we have some more esoteric features like freeform, which is basically a push and pull NURBS modification tool for an existing surface. The boundary feature was introduced in 2007. It really was started as a project around 2004. And it was conceived because at this point in time, industrial designers were looking for a more versatile, higher quality surfacing tool, namely one that could do curve matching or equal curvature on both first and second direction profiles. In addition, looking for a bit more quality and more versatility and options to create surfaces that could not be created up to that point. I put the Scooby-Doo model in here because actually Mike Wilson did a lot of beta testing for the boundary feature, and this model was important in defining the boundary feature. So the boundary feature is versatile in that, unlike Loft, you can create a boundary between just two curves. So in this very simple surface on the left here, we have one first direction curve and one second direction curve, and from that boundary can derive a general surface. Of course, you can do, like Loft, you can do just two or more first directional curves, or you can, as I often do in creating reference surfaces, create two first direction curves with just a single second direction curve, or as shown in the example here, just a single direction curve and two second direction curves. So one way that is important to not use the boundary feature is if you have a surface that you're defining where the first direction or second direction curves have a common endpoint. Now, SolidWorks will allow you to do this feature, but if you turn on curvature or face curves, you'll immediately see that you probably won't want to do this feature this way. By the first directional curves or second directional curves having a common endpoint, the boundary or loft will create, but it'll create what I call a degenerate vertice or vertex, where you can see that very clearly in the face curves here, how the surface will build itself, but it'll really build itself by defining its direction down to that common vertice. And what that does is results in a not so well-intended surface. And especially if you go to try to shell or offset the surface, you will not be able to. The alternative to this, which is fantastic in SolidWorks, is that you can use the fill feature instead. So I often define the uses for fill to be if you have a surface to create that is 3 or 5 or more sides, then use fill. If it's 2 or 4 surfaces, use boundary. And you can see here, by defining 3 boundaries with the same edges that were used in the boundary feature, the fill feature actually can define that shape without any degenerate vertices. It does that because it's a unique algorithm that calculates the UV not by the surrounding boundaries, but by a generalized direction. So a few more things about the boundary feature that makes it unique over Loft and why it was conceived is Loft is very similar, but there are some subtle differences. Namely, Loft is really defining profiles and then guide curves. And they're named distinctly because they are distinct. The profiles take precedent over the guides. In other words, the profiles have more influence than the guide curves do. And so with that, you'll get some unexpected results if you're trying to fill a patch, whereas with boundary that doesn't occur. So with this simple graphic here, you can see if you think of a blanket that's being stretched, the profile humans have more force or pull than the guides do, and therefore the shape is biased from the first and second profiles. If you compare that to the boundary has equal influence on all 4 sides. So there is no bias between first or second direction curve. They're equally weighted, if you will. And this makes it valuable in that you can probably create many more features with Boundary than you can Loft. Now, there are certain circumstances where Loft is more valuable than Boundary. If you want to create a general kind of Loft sweep, then you'll want to use a Loft over a Boundary, because Loft will do that if you recognize that the profiles take precedent over the guide curves. Another important distinction between Loft and Boundary, and another reason it was conceived, is that with Loft, what's really happening underneath the covers, if you will, is it's taking the profile and creating temporary profiles along the guide curves to define that surface. So what results is you get something that to the human eye looks correct, but there are minute differences along the guide. The guides are approximations. Remember, they're approximations based on the temporary profiles that are created invisible to you. And because of that, sometimes it's hard to knit or match guide curve edges of lofts. So this also doesn't occur with Boundary, because Boundary gives a very accurate result at either first or the second direction curves. Another important feature of Boundary are connectors. Now, Loft has connectors, but they're only in the profile direction. They aren't in both the profile and guide curve direction. With Boundary, you have connectors that you can define in both directions. And they generally work better in Boundary. They're a little bit more thought out there. And you can see with this spoon detail, and I can bring this model up later to show you, the ridges or butt cracks, as we call them, are created merely by connectors, by positioning the connectors and getting that detail into the surface and defining that surface by those connectors. Another important feature of Boundary is the way it is integrated with the selection manager and the option or control you have to actually define curves on the fly. That is, you have little meatballs that you can move to delimit the curve. You can also use options called trim by one or trim by two direction. So you don't have to actually explicitly define the portions of the curve that you want to build a Boundary feature in. You can select the general curves and then let these options just define the area that you want to build to. So very useful. It really reduces the number of total features in SolidWorks to have this feature. Another control that you might notice in the Boundary Feature Property Manager is the curve influence options. And on this particular example, and I can bring this up just a bit later too, to illustrate it, you have ways of giving options on how the boundary surface is actually built. That is, controlling the flow from the first directional curves to the second directional curves. You can define to a linear edge globally, to next sharp, to next edge, and I can show you the subtle differences that in that model that I'll bring up here. So why don't we get into a few models and just illustrate some of these features, and then walk you through how the boundary feature is actually used in some models that I have here. So with this model, we have the classic pillow shape, and this might be the back of a mobile phone or some handheld device, but it really calls for some care in creating a surface that's very smooth, has good continuity, and generally can't be done with just basic modeling tools. So let's take a look at this model, and I'm going to roll back here, and I think what I'll do is I'll just delete these features and keep their sketches, and from that point we can just start to rebuild it the way that I built it. So first off, we have a general profile of the phone, and then we have some basic curves that define the very large arcs of the back. So one of the first uses of boundary feature is, I remember I had mentioned that you can create a boundary by just two curves. So we're going to do that. And with one first direction curve and one second direction curve, you have a boundary. So with that, I take and I'm going to create another sketch in my top plane and then trim that. But before I do that, let me back up and show you a few more features here that make this more useful. So you know how I had just picked these sketches themselves. An alternate way to do that with a bit more versatility is to use the selection manager. And as I use the selection manager, I get little pull handles at either end. Now, because I'm building this model 1/4 at a time and then mirroring it in two directions, I really just wanted to find the one corner and then mirror it by 4. So I'm going to build my surface that way also. So here I selected with the selection manager this curve, pulled back this point, and I'm going to do the same for the second direction. I'm going to keep the selection manager up. You can pin it and then pull back a point. And now I've just defined the boundary by just these portions of the curve. I need to go back in, and while I'm here, I want to make sure that I assign normal to profile for both of these. Now, the center point is right off of the front and right planes for both these arcs. So I know by making it normal to profile in both these directions, I'll have tangency at the front and the right plane. Let's just turn off our planes for a moment there. So here again we have that surface. We're going to bring up our trim curve and do a trim on the back end, just that 1/4. I'm going to keep this portion here. Okay. And then I will go ahead and create a few more curves. This one down here is just defining the boundary edge at the parting line, and I've probably used a fit curve through all of that because I want to keep it as one curve to get a little smoother surface. And then I'm going to create my edge curves, and because I deleted some things here, I'm going to have to do some reattachment. So let's go ahead and just bring up our display delete relationships, delete our dangles, and then reattach. So I'm going to click here and make that C2. And then let's do the same for our other curve. So again, display delete relationships, look for dangles, delete them, and then reattach. Okay, I think we've got everything we need. So now we can get to the business of creating our corner boundary surface. This is, again, this qualifies for boundary because it is a two-direction curve. Here we have our first direction curves, and then the boundary of this back is the first of the second direction, and then down here is the second curve of the second direction. Let's hide this so we don't get confused. So we're going to go ahead and use our selection manager again, and you see we have this little helper here that allows us to pick tangent edges, and we can assign that as tangent or curvature. Let's do that after we define everything else. Here we have a single fit spline, so we can use that. And there we have our first direction. Now we go to our second direction and pick our second direction, first and second curves. And then we're at a point where we can just start defining what we want our tangency or end conditions to be. These are normal to profile. And then this one, I think I probably want to have curvature, and then none on this. So there we have it. There's our corner boundary surface. Now, let me edit it again and show you a few important distinctions. So I talked about some of those curve influence tools. And if we put our preview right about here, by default, the boundary will give you a global result of all the curves. But let's try next to curve. Since I have this curve here as my second direction first curve, second direction second curve, I want to try to pull out this corner, and I believe I'll be able to do that by selecting the option here to next curve. And you can see there that it did pull out that corner a bit. And that's what this feature is good for, is if you want to try, if you're building boundaries and it's wrapping around corners and you want that corner to fill out just a bit more, this is a good option for that by using next curve, which you can see there fills it out. Okay, and then sometimes you get just a little too much influence on the boundary here. We'll take a look at that with some zebra and see what we get. But at this point, we've got everything that we need. We can knit these two surfaces, and we can turn on our tangent edges removed. And we have a problem here with this curve because I'm seeing that it's not tangent. If we turn on these curves and go to our evaluate deviation analysis, we can see that we have a bit of a problem around this corner here. So let's investigate that. Let's go back to the boundary and check our conditions. Well, this is one of the things about boundary is, remember that next to curve that I assigned here? When you do that, it for some reason, and I'm not sure if this is a bug or a feature, but it resets the boundary. So we've got to reset that back to curvature. And now all is well, because you can see there's no more edge there when we have our tangent edges hidden. So just keep that in mind as you start to use many of the options in the boundary feature. Go back and check to make sure that it doesn't turn off other options. So we're going to take this right plane and we're going to mirror it along that right plane. We're going to mirror the body itself. So that is the surface body. And we're going to knit it and then hit my enter key again and pick my front plane. Pick the mirror body and knit that. And so now we have pretty much the definition for the back of our handheld case or mobile device. If we turn on our curvature, you can see that we've got some really nice curvature there on the back. And if we turn on our zebra, and I like to use as an alternative plain sky because I get just a single edge, you can see I've got a pretty good curvature along that corner there. So there you go. So that's just a quick introduction to the boundary feature. Now let's talk a bit about some of those options I mentioned earlier in the PowerPoint slides. One of them being connectors. And so we have this classic spoon model, and I'm going to roll back to my boundary that was used to define the handle. Now, let's just understand how this was constructed. If we turn on our sketches by selecting these and showing them, let's turn off our planes. Excuse me. We have basically our first direction curve is this teardropped profile at the end of the spoon, and then in the second curve in the first direction, actually it looks like there are 3 first directional curves. There's this transition arc here, and then this very end edge of the spoon itself. So the ladle part of the spoon was created using a boundary and then trimmed, and then this boundary was built on top of that. Now that little arc curve there that is placed in the first direction is actually pretty important. I'm going to explain why. So let's edit into the boundary. And first thing you need to know is that these connectors that I created here, let's just eliminate the connectors and then let me redo them so you can see how they were done. So if you right click on any boundary, you can say reset connectors. And it's not working for some reason. Let's just delete connectors. Okay. So when you build a boundary and the first direction or second direction curves don't match each other in number of entities, you can see here we just have a single edge and a single arc, but here we have 3 arcs. It's going to have to decide how to actually build that surface between dissimilar entities in those curves. So it tries to approximate and fit the flow of the surface, and you can see that here. If we just regenerate, it does a pretty good job on its own of doing that. But if you want to modify that or change it a bit, you have the ability to use connectors. So let's go back in and let's turn off our selection manager. Let's get some of these tags out of the way. And we're going to build a few connectors, namely 2 of them. So if you right click here at this vertex and say add connector, let me do it again right here, we can, it's going to build a connector, or what, if you will, a kind of temporary quasi-curve that defines the shape of this surface. And you can see, if I start pulling these around, you can see these interim edges will actually update on those. And that's where it becomes very powerful to be able to influence how the surface is actually flowing. And that's why I put connectors here, because I want these to somewhat spread apart. And you can see that I've actually created some points in a sketch. And that's a good thing about boundary, is that, connectors, that you can actually snap to geometry, and that's what I'm doing here. So they can be parametrically driven. These points are dimensioned. So you have that ability. And here I want to space these out just a little bit more. And then I solve my boundary. So there you can see you get a nice flow from the end of the spoon handle to the ladle. I believe there's another boundary here where I'm using connectors. So let me find that. And looks like because we eliminated some of our boundaries here, we have something that we need to repair. So it's probably this edge right here. Let me reload the model and show that to you. So let's go back to our spoon model. And then roll to that boundary. Yeah, I believe it's this one right here. This probably shows the usefulness of connectors even more. If I get on my camera view here. So this boundary right here, there's really an important use for connectors on this. If I were to just remove this connector and go to a top view, I really want this to come off straight instead of curve back. So I'm going to create a connector right at this vertice, and then I'm going to pull this so I get it to kind of flow straight in, or just a little bit more tangent off of this edge here, so I can get the look I want. So you can see how this is diving, it's kind of diving up a bit right here, and that's what I'm using my connector for, to try to make that look just a little bit better. Actually wants to come down. So there, you can see the dramatic difference that the connector can make in solving your surface to make it look much nicer. Another thing that you have to keep in mind, is just a little thing, is that I have my selection manager pinned. It comes up every time I create a boundary surface. With the selection manager up, there's things that you cannot do, and you need to close it first before you can go and work on the connectors. So that's just a little thing to keep in mind. Another option for boundary that I want to bring to your attention that I mentioned in the PowerPoint slides is the curve influence. And here's the model that was used in that slide. You can download this model and check it out for yourself. If you go into the front view, I'd recommend going into the front view and then going to the different configurations. So your default is global, but if you then start clicking on the different configurations, you can see the different solutions that are achieved by just changing this option. And they're all pretty subtle, and some are not so subtle, like the next edge. Let's go back to just the global configuration for this, and let's just edit into it, and I'll explain some of these. So let's turn off our selection manager. Now, if we don't have any second direction curves, you're not going to get these options, because it really can only build the boundary between the first directional curves, and there really is no other solution. So you'll see these options start to appear as you start to use curves in both directions. So if we click on one of these curves, you're going to see that you start to get the global, but global is the only solution because there is only one curve, and so therefore the global solution is along one curve. Now let's just keep adding, and now we start to get more of these options, because now you're introducing some so-called ambiguity into the model, and the boundary needs to know, what do you want to do with these curves, where the curves are only defining certain portions of the model. What do you want to do between those curves? That's really what it's asking you. So with a global solution, you basically get something that solves for all the surrounding surfaces and uses these three curves that I selected to do that. If we go to some of the other options, so let's go to next curve. Next curve will be very similar, but what it's doing, and if we put it in the front view here, let's go back to global. You can see going from global to next curve, what it's doing is it's then saying, it's using the curves to say, how do you want to build this surface between these curves? So if we go back to global, global is just giving a general solution between those curves. It's not paying attention to the actual curve direction and its placement. If we go to next curve, you can see now that the curves are more greatly influencing the surface, especially between curves. If we do something like next sharp, then what it's doing is it's saying, go to my sharps, which are these points or vertices in my profiles in my first direction, and make the solution sharp. I purposely left out a curve here to show you that. These curves are still defining the shape because it is using these as the second direction curves. If we were to start to eliminate them, you can see that it's now, let's go back and try to get next sharp. I think if we eliminate this one, what is this one? Okay. You can see that this curve, if we go down to this one and do next sharp, we basically get it just solving between these two curves and this sharp. So you see it gets rather flat here. It just doesn't it ignores this curve because I didn't pick it, but it's just doing the surface solution between this curve and this sharp. Let's add this back in and then go to next edge. So with next edge, you get something even more radical as a solution, where you're just solving to the next edge and then to the curve and then to the edge. See, there's an edge in the model right there, so that's why that's being included. Let's try linear. So linear, I think, is pretty similar to global, especially with all these curves selected. If we just toggle between linear and global, you can see pretty similar, but you do get some slight variations in the solution. So I think the bottom line is that you just experiment with this to get the kind of shape that you want, and it's great that SolidWorks gives you all these options because one might be just the right one for you. So I think that's all we have time for right now in this first part. I'm going to continue a second part for Boundary, and we'll get into some more model building and some more nuances of building some shapes with Boundary. I'll see you in the next episode.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.